Good afternoon everyone, and welcome to the second video in our three-part series. In this video we will be showing you our working configuration for our NTRIP Caster or base station, where we have a very accurate position of the antenna already established as discussed in and explained in the first video of the series. And from that we will be configuring our GNSS receiver, the different flags and all the data messages that we need, and how we're going to transmit that data stream with its corrections to a server on the internet. From there we can take those corrections and deploy to our rover or NTRIP client in the field to get up to 14mm accurate geolocation services. So going back to use center, for now I will just be reverting the receiver to its default configuration to ensure that we start with a clean slate once again. I already have the ECEF coordinates for our own antenna. These will still be updated in due time once we get more accurate coordinates, but these will just be used as an example for now for our configuration here at Engineering 4.0 at the University of Pretoria. We want to first specify the very precise position of the antenna. So we'll just copy and paste these values over, and there we have the accurate position. I'll send these coordinates into the GPS and we have that configured now. Moving back to our messages terminal over here, first thing we're just going to ensure that the raw X measurements have been disabled from the previous example. Even though we did reset the GNSS receiver, we can still just confirm that that is in fact the case. And there we see that we have no raw X messages enabled, which is correct. Moving on, we'll go to our what we call RTCM correction messages. This is received this is provided by the receiver, the corrections themselves. So once we know the position, we can accommodate the errors induced by atmospheric conditions, gravimetric differences, Doppler, and inaccuracies in the timekeeping of the satellites themselves. And for this particular receiver and the different bands that are currently used, the following messages needs to be enabled. The first one is F5-05, and we only need to enable this on the USB interface, which is the interface that we are using. Then the next one is 10770 on the end, or F5-4D. So all of the messages ending in a 7, I believe that is to do with the new generation of receivers. So we'll enable that one as well. So 1077, 1087, or F5-57. And then the next one, 1097, or F5-61. Let's enable that one. Then 1127, or F5-7F. Then 1230, or F5E6. Then 4072.0, or F5-FE, and then lastly the 4072.1, or F5-FD. Enable that on the USB interface as well. So the NMEA GG messages should be enabled still. We can see that that is in fact the case. So we need the GGA, GLL, GSA, GSV to be enabled. And then the other messages are disabled. If this is not the case, we can simply disable that on the interface. And again, this is for our own working iteration or version of the NTRIP Caster. If this can remain enabled, by all means do so, but this is the configuration that we, through trial and error, have found to be working correctly. So the other NMEA messages appear to be disabled, which is correct. And as mentioned before, the RAW-X messages should also be disabled. We already confirmed that. Next, we want to also confirm that the navigation messages are disabled. So you'll see over here closer to the top, we typically on my list will start with SVN. We can see that that is in fact disabled. The status message should also be disabled, which it is. Then SLAS, which is also disabled, that's correct. SIG, or I believe short for signal, also disabled, which is correct. SBAS. That's also disabled. And then SAT, believing short for satellite, disabled. Relative positioning, disabled. And then the other navigation flags, that's showing our horizontal degree of precision, I believe. So all of the navigation messages are disabled as per my notes. And then finally, to ensure that we are in fact receiving the or rather communicating correctly with the different ports, we can go in our configuration window. There's a tab named ports, which I'll click on over here. And then for UART1 and UART2, this does not really impact the functionality, but for the sake of completeness, the current configuration which I am using, I tend to prefer a higher baud rate or communication rate of 115/200, just to ensure consistency across the board. So we'll change that to 115/200. We'll send that through. Then UART2, we have RTCM3 messages for both in and out, and again I'll change the communication rate, and this is important especially for the rover and the Bluetooth module that we're using to push in correction data from a cell phone using an Android app, where the Bluetooth module also is 11.5/200 baud rate, so that's why we just prefer to set everything as is. And then most importantly, we go to our USB interface, which is the one that we're currently using. And then you will see that it's 0+1+5 for both UBX, NMEA, and then our RTCM3 correction messages that are required. So that's the selection for both the protocol in and out, but that is also set by default. Once this is done, you should see here on the right hand side that we see the fixed mode is now 3D. Sometimes it will add DGNSS. It should not show time mode at all. And you will note that the satellites don't always update either for this particular fixed mode of the receiver. So in its current configuration, we are streaming or sending out correction data that's generated by the GNSS receiver based on the observations that we can see after we've provided a fixed coordinate of the receiver. which we did right at the beginning, and which we can get either approximately accurate using the server in mode, or very accurate using the triple P mode, which will take quite some time. So with that configuration out of the way, we first need to disconnect the receiver to ensure that the other software utility can actually access the COM port itself, COM port 12 in our example. So I'll just click over there and you'll see no new data is pushed through to the system over here. Our software package of choice to transmit correction data, it's called SNP. This is also free to use. If you need to register an account, again, it will also be free. And I'm currently using just the single caster version. I believe there are some limits on the free version, but it's more than adequate for a single NTRIP Caster application. So here on the top we have a number of different tabs. The two most important ones for our application is the serial stream. This is where the data comes in, and then of course the push out stream, where we are sending the data to a particular point or server. The SNP software application, we will first need to register an account with RTK2Go. So that is a global initiative, not exactly sure whether it's open source, but a community driven idea where we can send our correction data to a particular mount point, so a station with a unique name, and then anyone else in the region or in the world, in fact, can access this correction stream. So as part of the service, they are also running a type of SNP interface, and with that, it will automatically pass this raw data, ensure that it's the correct type and format and messages type, and makes it available over a internet connection, which is very handy if we're going out into the field with our rover unit. We can simply take a cell phone to pass these corrections in. So once you've registered an account, you can create your own mount point with a unique name and password. Password is only required if we're submitting or transmitting data to a particular endpoint. So back to SNP, this is where we're going to take our serial stream data. So this is the third tab. You'll see COM port 12 over there once again. We're going to take this data and we're going to push it to that particular mount point on RTK2Go. So that is where the push out stream tab comes in. And you will see that we already have that configured for this example. If you want to add a new serial stream, you can click here, add new stream. We will click next. We will select the applicable COM port, in this example COM port 12. You can see the right with the correct port rate. Next, we wish to configure that. Before we click configure, I'm disabling the logging functionality, otherwise we run out of disk space rather quickly on the small computer, and we want to ensure that we pass the RTCM messages. Once we click on the configure button, a new window will pop up where we can configure exactly the details that is required. So our mount point, if you will, can be practically any name. Keep in mind that this is the input stream. So for our example, we named it Inch4, like with this particular example. And we can state that our city is Pretoria, our country code is Zulu Alpha Foxtrot, or for South Africa. We can also detect the type of data using auto detect, which is something we definitely want. Again, we'll enable the 4 constellations which we know we are receiving data for. Our location will just be an approximate one where the antenna is located, so I believe it is approximately correct. The current coordinates, 25 degrees south, 28 degrees east, and then we would click OK, next, and then this will be added to our serial input stream. So I'm not going to duplicate that for this example just now, and then I'm just going to close the window. So once we have the serial input stream configured, if we click right click on the entry, We can now say that we wish to connect to that serial stream that is available. That's the GNSS receiver. So once I click connect on that serial stream, you will see that it's starting to receive input data. Normally it will run a brief analysis on the data stream once we first create it, but the format stays largely unchanged, so it's nothing to worry about if you see that. We can even view the type of data once again that comes in, similar to the ublox packet console or packet viewer. If we right click on this entry, we can also say to show the message types. So let's click on that. And then you will see the different RTCM correction messages which are currently being received. So just disable that. A quick and easy way to find out whether your stream is actually receiving the correct type of information is if we go into the RTCM3 viewer. You will see a window that looks very similar to this. So this is the messages of the RTCM standard, 1005, 77, 87, 97, all those that were configured earlier in the ublox. Software utility, you can see that the counts are going up in once per second. That's the rate at which it receives this data. And then the number of satellites associated with each. Being the light or the free version, you cannot see all of the available details, but with the pro version you can see even things like the Doppler effect. So once we know that everything is correct over on our serial input stream, it's now time to configure our output stream. So we go to push out streams. We can then again say add a stream. So this is if you have not configured a mount point yet. In our example again, it's going to be RTK2Go. So from our stream, this is the input stream. We only have one available device. Of course, that will be ENG4, the one that we call the input stream. And then for the mount point name, that refers to the mount point which you registered with the service. In our case, it was again RTK2Go. So we will call this engineering 4. Then the remote URL or IP will be www.rtk2go.com. The port is 2101. We can then set the particular password for this mount point. You will have set this password when you registered a new mount point. I have the password for the engineering 4 mount point. You will then enter this password now, whether it's 1234 or something similar. You enter the password that you configured. So this will give you the right type of access to actually push data to that mount point that you configured on RTK2Go. So once that is done, we have now successfully set the stream that it's being received. So we're passing that input data stream. It's getting all the RTCM correction messages. We configured those to be pushed to RTK2Go. So prior to us starting this stream to RTK2Go's service, let's just quickly open up the status page for this particular mount point of ours. If we go to rtk2go.com, semicolon 2101 /snip, semicolon mount pt question mark name equals. This last portion of that URL, you can specify the particular mount point. If we then query this web page, it will give us the current status of the NTRIP Caster. Since we're not sending data just yet to this service, you will see that it only says that it was active at one point in time. If we go back into our snip utility, we have the serial input stream pushing in data. You can see it's not too much data, but it is actively coming in. And we will now activate our output stream, taking this data from the receiver, sending it to the server. So I'm going to click connect. And there you will see that the uptime is climbing very slowly in number of seconds, 8 seconds, 9 seconds. So we are, it appears, connected to RTK2Go, and you can see there's a few statistics down here sending that data through to the server. We can once again go back to our Internet Explorer, or Internet Browser rather. And if we refresh this page, we should now see that the mount point is in fact active. And there we can see all the results. So there's our coordinate which we specified earlier. This is the fixed coordinate of our antenna which we got via either TRIP or the server in method. Here you can see the message format is RTCM3. These are the different messages once again that appears correctly on the page. You can even see the number of satellites in view. So GPS, GLONASS, not sure about QZSS. We have Galileo, and then of course Beidou as well. So quite a number of satellites. And you can see we've had an uptime of 37 seconds at the time of loading this page. And this essentially means that the correction stream is working correctly. This data stream is continuously being sent to the server and is now available for our rover to use in the field. So in the third and final video of the series, I'll be illustrating our working configuration for the rover. It's similar to the NTRIP Caster or the base station configuration, with some slight alterations, especially for the input ports. Once that is done successfully, we can use the Android app, which we'll also explain, to connect to the server. And using our LTE 4G connection, we're going to take the stream of data and then push it in over a Bluetooth interface into our RTK receiver, where it automatically combines these corrections to provide us with RTK capabilities, getting that 14mm accuracy geolocation service. So see you in the third and final video.